Hello, students. I welcome you to in this another video tutorial in the series of computer system architecture. And in this tutorial, I am going to discuss in detail what is half adder and full adder. So half adder, what half adder does, it add 2 bits. Add 2 bits. And what are the two bits? 2 bits are the binary digits actually, and you know that in binary we have two numbers only, 0 and 1, and the combination of these 2 bits are 4 because we have the 4 combinations in a way that, as you can see here, we have the two numbers x and y, two variables, and then the 4 combination of the 2 bits 0 and 1 is first is 0 0, then 0 1, 1 0, and 1 1. And when we add, as we have learned in our school when we were in first grade, or in our UKG or in LKG class. So we have learned that when we add two numbers in decimal, what we get a sum and a carry, which is carried to the another place in the number. So in the same way, we have, when we add 2 bits in binary, we have two outputs, carry and sum. So I write C for carry and S for sum. So when I add 0 and 0, then what we get in sum is 0, and there is no carry is generated here. And when I add 0 to 1, so I have sum 1, and the carry, again the carry is not here because the carry is not generated in that case. And in this third combination, when we have x is 0 and y is 0, when we add these two, so again we got sum as 1 and we have carry is 0. But when we add 1 to 1, so when we add 1 and 1, we got 2 in answer in decimal, and in binary we got 1 and 0, right? So you can see here, like we have 1 1, when we add this we got 2, and in binary, if you convert to in binary, so we got 1 0, right? So this 2 is in decimal and 1 0 is in binary. So the sum is 0 and 1 is carried to the another digit if it was there, okay? So 1 is carried to another digit. So in that case, we have sum is 0 and the carry is 1. So I hope you understand this thing, and I again repeat it. When you add 1 to 1, we got 2 in answer in decimal, and when we convert 2 in binary, so we got 1 0, right? 1 0 is 2. So this 1 is carried to another this digit. If suppose we have some digit 1 or 0, so it is carried to this digit and then it is added to that, but it's not there, so the carry will be here, right? So in this table we will write 1 in this carry column, and the sum is 0, right? So now what they ask in your exam, that what is a half adder, and draw the truth table for half adder and also design the circuit. So how to design a circuit? As you know that for these output, because we got two output in the form of C and S, so what we will do, we will make a Boolean function, or we will find out the Boolean function for C and S, right? For C and S, right? So to find out the Boolean function for these two variables, for these two outputs, carry and sum, what we have to do, we need to draw the K map for C and S individually. So for C, firstly I will draw for C. So as you know, because if you don't know how to draw a corner map for these variables and what is K map, so you can watch my another videos on K map simplifications, right? So here we have the two variables, right? So in K map, which is nothing but a pictorial representation in which we have some cells and we divide these K map into some cells. So what will be the number of cells in a Karnaugh map? It is equal to the 2 raised to power n, because the number of cells will be in that formula, where n is the number of variables. So in this case we have two input variables x and y, so the value of n will be 2. So then we will have how many cells we will have in this Karnaugh map? It will be 4, right? Because we have the two variables here, x and y. So that's why we have calculated 4. So we will divide this K map into 4 cells. Now you can see that I have already divided it into this form, and then we will place 0 here because for x we have two values. X can be 0 or x can be 1, and again for y we have two values, 0 and 1. So for each of this combination we will see that for 0 and 0, then when x is 0 and y is 0, the C is 0, right? So when x is 0 and y is 0, it will be 0. When x is 0 and y is 1, it will be 0. Here you can see when x is 1 and y is 0, it is 0, because x is 1 and y is 0, it will be 0. And then we have x and y, when both x is 1 and y is 1, the C is 1. So here we have C 1. So now what is the next step when we are going to simplify this K map is we look for the ones in this K map. So we have only one in only one cell, okay? So here we cannot group, because this is the only cell that we have one, okay? So in that case what we will do, we will write its value. So its value is x and y, both are present, so that's why C will be x, y, right? C will be x, y. So you can also directly write it from here that x is 1 and y is 1, so C is, because the only value of C is 1 in this case when both x and y are present. So that's why we have written C is equal to x, y, right? And for S, what we have to do, we have to draw a Karnaugh map, and it will also be a 4 cells K map, because we have only two variables x and y, as we know. So let's draw another K map for this sum, right? That is x. So for x, y, again we have this 0 and 1, and for y we have this 0 and 1 here. So now so in this step I'm not going to write this 0 and 0, because we know that when we evaluate the product of some form we consider zeros, otherwise we consider ones only. So because you understand what is mean by 1 and 0 in sum of product and product of some form, and if you have missed those lectures and this is not clear to you that what is a sum of product form and product of subform, please do watch the previous videos on this topic, and the K map simplification in 2 variable map, 3 variable, and also I have simplified the 4 variable K map, and you can practice it your own, and then you can ask me questions about these the concept of K map, right? So let's come back to this K map. So we have 1 and 1 here at these two places when x is 0 and y is 1, and when x is 1 and y is 0. So when x is 0 and y is 1, so we have 1 here, and when x is 1 and y is 0 is 1 here, right? So you can you have placed the ones here. Now you can see that there is no grouping of these ones, because in that case the adjacent cells only make the or participate in a group. Okay, so we group the cells which are adjacent to each other. So but here the cells with 1 having value 1, it's not adjacent to each other, so they are diagonally adjacent, not side by side. So that's why we cannot make the group. So here what we have to do, we will write the function in x and y. So let's start from this cell. So this is when x is 1 and y is 0. So when x is 1 and y is 0, so what we will write, we will write x is 1, so we will not complement this x, and okay, and then y is 0, so that's why we will complement this y. So we will write like x y complement, right? And then we have this, for this cell x is 0, so that means x will be complemented, and y will be same, right? Because y is 1. So again, because we are considering 1, so we will evaluate in this sum of product form. Then this will be x y complement plus x complement y. So we have simplified these two k map for carry and sum. So now we have to design a circuit, but before that, if you look for this this column for S, right? So if you know that what is the logic circuits, right, and how and you know the logic gates, so if you look at it carefully, you will see when both the inputs are different. So S is 1. So S is 1 only when both the inputs are 1. Both the inputs are different. So this is the truth table for the XOR gate. So I will write it here that S is X XOR Y, right? S is X XOR Y, right? So if you if you are not remember, and if you are not reminding the truth table, you can look, you can watch it. You can watch my video on the logic gates. That was the first video in this series of computer system architecture lectures, and you can look it carefully that this is the output for the XOR gate. Okay, so that's why I have written it X XOR Y. So let's design a combination circuit for this half adder. Okay, so here we have the X and Y. These are the two inputs, right? X and Y. And for C, we can directly take these two X and Y as with AND gate, because this is the dot product X and X dot Y. So this is that will be for C. And again for X and Y, we will use the XOR gate. Okay, so XOR gate will be like, because you know the symbol of XOR gate. XOR gate symbol is this. So that will be the symbol, that is the symbol for the XOR gate, and so that is your S. So this is your half adder, right? So this is your half adder, and which adds two binary bits. And let's quickly revise this concept. So half adder adds two binary digits, which is 0 and 1, and what are the possible combinations for these two bits 0 and 1, and this is the combination is 0 0 0 1 1 0 and 1 1, and I have written out all the combinations here on the right hand side of this table, because I have parts into two parts, because because we are adding two binary digits, so that will be x and y, and the outputs are C and S. C is for carry, S is for sum. And then what I have to do in second step, I have draw the Carnot map for these both this C and as well as for sum S, and then we come out with this Boolean function after simplifying this K map, and then we draw this logic circuit. Okay, so I hope that it is very much clear to you, and thank you, and if you have any queries, so please let me know in the message box. Thank you.